In this topic, we take a look at rational expressions. We start with an introduction. So what exactly is a rational expression? Well, by definition, a rational expression is a fraction whose numerator and denominator are each a polynomial. Let's take a look at some examples. Here, x squared plus 2x plus 1 divided by 2x plus 5. X plus y over x squared y plus 4xy squared. 5 over 2x minus 3. X over 5, 1 over x, 2 over 3. Notice, in each of these cases, we have fractions where the numerator and denominator are both a polynomial. Sometimes those polynomials have multiple variables. Sometimes they don't. Sometimes they're simply composed of a constant or a monomial term. In any case, anytime you have a fraction that involves variables that are polynomials, these are called rational expressions. I kind of remember it by thinking of the word rational and breaking it up into ratio. A ratio is a quotient, so I think of rational expressions as quotients of polynomials. Now, the cool thing is that since rational expressions are essentially fractions, we can work with them the same way we do regular fractions. We can simplify them, we can add them, subtract them, multiply them, divide them, all the same. So our rules of fractions will also apply when we work with rational expressions. So, we're going to start by taking a look at rational expressions, and first we're going to evaluate them for specific variables, and then we're going to talk about something called where they're undefined. So, let's get started. We begin with evaluating rational expressions. Note that rational expressions take on different values as the variables change. Determining the value of an expression at a particular value of the variable is what we call evaluating the expression. So, for instance, suppose we were asked to evaluate the rational expression 5 minus x over 2x plus 4 at the value x equals 1. Well, to evaluate the expression at x equals 1, this means we must substitute the value of 1 everywhere that we see an x in the expression. So that is 5 minus x over 2x plus 4. If we plug in 1 for x, we get 5 minus 1 over 2 times 1 plus 4, which we simplify as 4 divided by 6, because 5 minus 1 is 4, and 2 times 1 plus 4 is 6, and this simplifies as 2/3. So that means that when x is 1, the value of this rational expression is simply 2/3. Let's try some of these on our own. Example 1. Evaluate x squared minus 16 divided by 2x plus 7 at the given values of x. A, x equals 1. B, x equals negative 5. C, x equals 4. We start by evaluating x squared minus 16 over 2x plus 7 at x equals 1. This means anywhere we see an x in our rational expression, we are going to replace it with the value of 1. So let's start by rewriting our rational expression, x squared minus 16 all divided by 2x plus 7. And then what we're going to do is, instead of putting the x's in, we're going to put the value of 1. So if we're going to evaluate this at x equals 1, we'll get the following. 1 squared minus 16 divided by 2 times the quantity of 1 plus 7. Now we simply work this out and evaluate this out. This is equal to 1 squared, which is 1, minus 16 on the top, and 2 times 1, which is 2 plus 7 on the bottom, and continuing to simplify down, 1 minus 16 is negative 15, 2 plus 7 is 9, and this is reducible because we can divide 3 into the top and the bottom, and when we divide 3 into 5 and 3 into 9, it gives us negative 5/3. Therefore, we say that our rational expression when x equals 1 is equivalent to negative 5/3. Cool, let's work the next example. B, x is negative 5. So again, we take our rational expression that we started with, x squared minus 16 over 2x plus 7. And this time, instead of replacing the x's with 1s, we're going to replace them with negative 5s. So we're going to let x be negative 5. And we're going to see what happens. So this time, we're going to take negative 5 squared minus 16, all divided by 2 times negative 5 plus 7. This gives us on the top, negative 5 all squared is negative 5 times negative 5, which notice is positive 25. So in the numerator, we have 25 minus 16. And in the denominator, we have a negative 10, 2 times negative 5, plus 7. Continuing to simplify, this gives us in the numerator 9, and in the denominator negative 3, and we can simplify that down because 9 divided by negative 3 is simply negative 3. So we say that our rational expression at x equals negative 5 is equivalent to negative 3. Awesome. Let's do the last example. X equals 4. So let's evaluate our polynomial x squared minus 16 all over 2x plus 7. And this time, in place of x, we're going to put x equals 4. Alrighty, starting on the top, we have 4 squared minus 16, all divided by 2 times 4 plus 7. This gives us, on the top, 4 squared, 4 times 4, which is 16 minus 16. And on the bottom, 2 times 4, which is 8 plus 7. So that gives us 16 minus 16, which is 0, divided by 15. And 0 divided by any number is simply 0. Wonderful. We have now evaluated this rational expression for different given values of x.